Good morning, this is Mr. Smith. Today we're going to be solving a quadratic word problem dealing with projectile motion. So we have Moon Knight jump from the top of a building. His height as a function of time could be modeled by the function negative 16t squared plus 16t plus 480, where t is time in seconds and h is the height in feet. How long did it take Moon Knight to reach his maximum height? So in these problems, I usually like to have a graphical representation of what's going on. So we have Moon Knight, and he's jumping from the top of the building. So let me slide this up. So we have Moon Knight, and there he goes. He has a little cape, and so he's jumping off the top of the building. But when he jumps up a little bit, and then eventually he's gonna hit the ground, and we'll make that the ground there. So as you can see, we basically have a nice little coordinate plane. So we know that our x right here is going to be our time, and we know that our y, which is right there, is going to be our height. So in this problem, the first thing they ask us to find is how long will it take him to reach his maximum height. So we know that right here, at the peak of our parabola here, that is our maximum height. So we need to find the x value. If we find that x value, we can find what time he'll reach his maximum height. So let's go to our problem. And it says, how long will it take Moon Knight to reach his maximum height? And we know it's the x value of the maximum, or the x value of our vertex. So we can actually use our axis of symmetry formula, which is x is equal to negative b over 2a. We can label our a, which is negative 16. We can label our b, which is positive 16. And we can label our c, which is 480. So we know our b is going to be 16. We'll put that in parentheses. And then we have our 2, and then we have our negative 16. So we get negative 16 in our numerator, and 2 times negative 16 is negative 32. We know a negative and negative make a positive, and 16 over 32 can reduce to 1/2. So in half a second, we know Moon Knight will reach his maximum height. So how long did it take Moon Knight to reach his maximum height? 1/2 a second, or half of sounds better, of half of a second before Moon Knight reaches max height. So the next question, it says, what was the highest point that Moon Knight reached? Well, we know the formula is h is equal to negative 16 t squared plus 16 t plus 480. And we know that the time that he reaches the maximum height is 1/2. So if we plug in the 1/2 for our t, so we plug in 1/2 for our t's here, we can find out what our maximum height will be, because the time of the maximum height is 1/2. So I'm going to plug in negative 16 I'm going to plug in 1/2 for t. Plug in 1/2 for t here. And a lot of students freak out because we got a fraction that we got to square. But we know that 1/2 squared just means 1/2 times 1/2. And what's 1 times 1? 1. What's 2 times 2? 4. So it's just 1/4. So don't freak out just because you see a fraction. Remember, to multiply a whole number times a fraction, we have to put the whole number over 1. So we have 16 over 1 times 1/2, which is 16 over 2. And 16 divided by 2 is 8. So I'm going to put 8 here. And then we got one more whole number that we have to multiply times a fraction. So we have negative 16. We have to put it over 1. Multiply times a 4. Multiply a fraction straight across. So we get negative 16. 1 times 4 is 4. Divide that. We know it's going to be a negative because a negative and a positive make a negative. And 16 divided by 4 is 4. So we have negative 4. And then we can just add. We have, let me slide up. Now we have negative 4 plus 8. So we get 4. And then we add those two. We get 484. So this is in feet. Because when we go back to the problem, height in feet. So we know 484 feet is the highest point moon night reaches. Alright, and now we have one more. The last problem says, when will moon night hit the ground? So we're trying to figure out at what point will he hit the ground. So when we go back to our little animation, rough sketch, whatever, we're trying to find this point. Trying to figure out right here when. So at what x value will he hit the ground? Well, if you remember, if we think about this, and we have, I'm drawing these little brown things here, and then out of the ground, we know flowers grow. So right here is roots. So whenever something hits the ground, whenever you see the word ground, you want to think roots. So we need to find the roots. All we have to do is find the roots. Once we find the roots, we're done with this problem. We know when it will hit the ground. So I'm going to rewrite the equation they gave us, which was negative 16. Slide this down just a little bit. Negative 16 t squared plus 16 t plus 480. And we need to factor this. When we factor this, we can find the roots. So before I try to quick factor or anything like that, I'm going to see if I can take out a GCF. That's what you should always try to do first. So when I look at this, I'm going to take out a negative 16. And I'll do ladder method. So when we take out a negative 16 divided by negative 16 is 1. So we have t squared. 16 divided by negative 16 is minus 16t. And 480 divided by negative 16, excuse me, minus t. And 480 minus 16 is 30. So now all we have to do is factor t squared minus t minus 30. And if you notice, our a term is 1 now. So the factors we will have, we know we'll have t, and we'll have t. So now we have to figure out what two numbers multiply to give us negative 30. and what two numbers add up to -1? I know 6 and 5 will give me 30, and if 6 is negative, I get my -1. And so I'm going to put -6 and +5. And then we're not done because we factored it, but we had to find out when it hits ground. We got to find out when the height is 0 because that's when it will hit the ground. So now we can break up each of these to individual mini equations, and we can solve for 0. So this one we have to add 6, so we get a time of 6. This one we have to subtract 5, and we get a time of -5. Well, hopefully you realize that we can't really have a negative time. So in this answer, we know that Moon Knight will hit the ground in 6 seconds because this is our answer. This is unreasonable. We'll put unreasonable. So we don't do that one. So to write my answer in a complete sentence, we know Moon Knight will hit the ground in 6 seconds. And that's your answer. These are the 3 main questions they can ask you. And the only other thing I can think of just off the top of my head is they might ask you what was the initial height, and hopefully you realize that's the y-intercept because that's where he would have started. So again, when we go back to the picture, what is the initial height? So where did he start? So at that point, that is time 0. So we just plug in 0, and then all you're left with is your C term, which would be 480 feet. Pretty much that's it. If you need to watch this video over again, please feel free to rewind it. I hope you have a good day.